Hello, welcome to another Magenta Academy video. So Magenta ran their annual Academy Live event at the Manufacturing Technology Centre on the 21st of April. This is a series of videos that collates all of the information from that event for those of you that couldn't make the event, so that to make sure that everybody gets to see all of the content and nobody misses anything out. So I'm going to be taking you through Inventor What's New 2016. My name is Joseph Hall. I'm an Autodesk Technical Consultant at Magenta Solutions. So, of today's topics, we're going to have sheet metal enhancements, we're going to have advanced manufacturing, and we're going to run through AnyCAD. So we've got 3 topics to cover, plenty of content to run through. So let's get a move on. Sheet metal enhancement. So there has been a significant improvement to the sheet metal capabilities within Autodesk Inventor 2016. And the significant improvement realistically is the ability to now work with multiple solid sheet metal bodies in a single sheet metal part file. So Inventor's had the ability to make multi-solid body parts for a number of years, but they've introduced this capability and this functionality into the sheet metal side of things. So this is going to let you work with multiple pieces of sheet metal in the same part file that can interact together, and then individually using the same workflows you would normally, so derive, make part, make component, to make individual components and then create the flat patterns of each one. They've also added a 0 radius bend option. So here's an example of having multiple sheet metal bodies and just highlighting 0 radius bends in there. So we're going to get straight into showing you functionality of this. So as I mentioned before, we're fairly limited for time, but I'm going to show you through the sheet metal capabilities. So I have here a basic sheet metal part file. Nothing too spectacular here, nothing too special happening with this. We're going to, as you can see at the moment, it has a flat pattern, so it already has a flat pattern defined. We are going to make a contour roll of the end sketch, and we're going to use that as the axis. So we're going to add something on about 90 degrees, and at this point here in the dialog box I'm going to specify a new solid. Now when I do so, Inventor will throw up an error message. This is expected simply because I have a flat pattern at the moment, and this dialog box is basically just telling me if I have a flat pattern already and I then start making a multiple solid, that flat pattern is no longer supported when multiple solid bodies exist. So I can accept it, pretty much delete my flat pattern because it's not able to create a flat pattern of multiple solids, and let's continue to make a lofted flange off the end 2 pieces as well, and again we'll do that as a new solid. So one thing to remember is to make sure that we rip this, because we want to make sure that we can point to point on that face, midpoint to midpoint. Where are you? There you are. So let's rip that up. So we'll make sure that we can unfold those. So I've got 3 parts here that all in effect react and behave linked together because of the power of multiple solids. What I'm now going to do is I'm going to go and make components. So I'm going to make an assembly from the 3 components that I have, so solids 1, 2 and 3. If I'd have named them in the tree, actually let's name them in the tree, so let's actually go in and name them. So solid 1 is going to be the straight, solid 2 is going to be the roll, and solid 3 is going to be the loft. So I've named those. So now if we go in and make components, we can make it from lofted, we can make it from lofted, straight and roll, we can next through. It's going to make an assembly, sheet metal part of each one, and then it creates me my assembly file. So if I just sort of spin this around, you'll see I've created my assembly file here of all the components that I want to work with. So that's great, works really well, but let's now open up each individual component, because each individual component will actually have a flat pattern. So I can flat pattern each one. Just zoom out so you can see, put the bend order annotation on if I want. Let's go back to the assembly file, open up the original part. So this one did have a flat pattern, but I had to delete it because I was working with multiple solids. Nothing too complicated about that one. And again, let's go back to the multiple solids and open the flanged one, flat pattern that one out as well. So I've now got multiple solids that are all behaving and working and being controlled and governed, if you like, by my master part file. So if I go into my master part file and I now have a look at the original sketch that was used to create this, so in the contour flange we've got a sketch in here, I can edit the sketch. If I need to change this, so for whatever reason, say the value of that goes down to 15 and the width of this increases to say 75, I can finish that sketch. That's then going to flatten that out and increase all of those components. That in turn will then filter through to my assembly, and in turn will then have an impact on the flat patterns of my straight, my roll and my lofted components. So now my lofted component is much longer in this instance. So what this means is you can create multiple components that will actually interact and behave together. So now if I sort of start having a look in here and start working and creating a flange on maybe that edge and that edge, I've now got two flanges, or I've got two flanges on this particular model that actually interact with one another. Maybe the distance of these is 5mm because they're being bolted together, and they are working. These are two separate solids, but those two separate solids I can actually have as those components. I could do the same thing on the contour roll if I wanted to, and again when I go back to my assembly, just give it an update and it will then update and filter that through to all of my other components. So if I use my cascade windows, let's get rid of home screen, use my cascade windows or arrange windows to be able to see all of these components. I've got my multiple solid part file. Oh, better. I've got my multiple solid part file, I've got my part here, I've got my assembly here, so these two are the same, and these are the three components that I get from each one. So maybe I go back to a folded part for this one and just have a quick look. This is what I've ended up with, so that works really nicely. I could do the same thing here, back to a folded part, just to give you an idea of what this is actually creating in terms of geometry. And again, all of this is controlled by my solid part. So if I in my solid part decide to edit the sketch, so I might decide that that's got to go up to 25 this time, or go up to, I don't know, 35 for example. Finish the sketch. That then changes that shape. That has an impact in this case on sketch number 4, so we can again edit that sketch. Let's go back from 40 to say 60 and 75. This one might be, let's go for 125. Finish the sketch. That's going to change my flange at the end, and then as soon as I come in here and I update this assembly, as soon as I update the assembly, you can see it will then filter through into my lofted part, into my straight part and into my rolled part, that all of that geometry is changing and adapting. So hopefully you get a good impression there of what you can do with multiple solid bodies within sheet metal. It works really, really nicely. It's a really effective way to work. Moving on from sheet metal, we're going to have a very quick look at advanced manufacturing before we focus our attention on AnyCAD. So advanced manufacturing, in this instance, we're talking about integrating 3D printing environments into Inventor. So now on the Environments tab, there is a 3D print icon. You can go into the 3D printed environment and you can work and arrange your model on a 3D printing bed. So there's a number of tools that we can utilize in here. So lots of tools like being able to split the component, add pins to make sure we can reconnect them, organize, position our components on the printer bed, use direct editing to scale the model up or down, and then when finished we can send the STL file to a printer. So we've got a quick video of this in action, if you like. So here's the environment that we're working in. I'm going to show you the first part of this video just to give us an idea of it. So here's the first video. We can have a look. You can see new direct editing functionality there with move, size, scale and rotate, and they're just going to use direct editing commands, scale it down, rotate it, position it, move it where it needs to be, and make sure that the component that we want to 3D print is actually printable in the environment. So it's really bringing forward all of the advanced technologies that Autodesk acquire fairly regularly to put all of this into practice, because 3D printing is becoming ever more present in the manufacturing world in which we work. So it's just a really, really good incentive, and this is the first intuition or first time this has been incorporated into the software. So there will be further enhancements, further advancements to be made in this that will help develop maybe potentially other things that can help us simulate this sort of thing, or make sure that we've got all the strengthening components in the right place. So what you're seeing on screen at the moment is a component being split and arranged and rearranged and snapped to another edge and snapped to a face. Just to give you an indication or an idea of that, I'm actually going to stop that there and move on from advanced manufacturing. So when we're talking about advanced manufacturing, that's the environment that we're talking about, 3D printing within Inventor. I'd now like to focus the final part of this video on AnyCAD. So AnyCAD is a real game changer within a CAD system. So Autodesk have the ability to work with native files from another CAD system without needing to import them into Inventor data. So they're of the understanding that in the world that we work, nobody works with the same CAD system in the same file format. Everybody works in different formats. So you may have suppliers that supply files to you in a SolidWorks format or a Creo format. So Autodesk have kind of taken all that on board, and they've looked at the market and kind of said, well, we want to make Inventor the product that everybody can interact with. And that's exactly what they've done. So AnyCAD gives you the ability to natively open files from another CAD system. There is no import into Inventor, as in, with this method, you are not importing files into Inventor. You can still choose to import and convert files if you want to, as you'll see in a moment. But this method maintains the native file and keeps the associativity back to that file as well. So this is where it becomes even more powerful. If you're working with a supplier, they supply you with a CAD file, you put it in your assembly, you assemble things to it, fix things in place. They then send you an email maybe 5 or 10 days later and say, oh, actually that design was the second revision, we're now on to the third or fourth revision of the file, I'll send you a new copy. In previous versions, that would have been a nightmare. You've got an assembly with everything assembled to it. Now they can send you the new file, you can put it in the same place that the Inventor is looking for that file, and when you do, it will simply update the file with an Inventor. So have an example, you might have another CAD system that sends you a file, you can put it into Inventor, you can update the import using the right mouse button, or it will manually or it will automatically update depending on what you've done. Really quick video. So we've got Inventor on the right, obviously SolidWorks on the left in this instance, and this is just an example of place an imported CAD file. They're going to place a SolidWorks part file. Notice in the box there really quickly that we're referencing the file rather than importing it, so they can position it in place using joints. Really quick, slick, easy way. Align the components and say OK. And then when we check it, it might be that this component and these two surfaces are off at a 10-degree angle, so they should be aligned together. So we can go back into our native CAD system where it's come from, SolidWorks, make the change and save it. Then when they come back into Inventor and update, the file will move. It's a really quick change, but hopefully you all managed to catch it. Also an example of Nastran in CAD as it's running in this case, some simulation on here. So if there are some individual places, some stresses on the model, you can natively have that linked to Inventor. You can analyze it, you can test it with an Inventor. They can then send you the new file. Then when you send you the file, it'll update the results. You can rerun the analysis as this is doing at the moment, and then the new results come through. When it's remeshing, now it's going to rerun the analysis, and the new analysis results will come through to say this is the results that we've got. So you can see this sort of information, or this ability to be able to import a native CAD file from another CAD system, is really useful. So what sorts of things can we do with it? So AnyCAD also gives you the ability to be selective upon import. So it's not just a case of, as it was in previous versions of the software, import, you have to have all of the assembly. Now you get to choose which parts of the assembly are relevant to you, which parts do you want to bring into Inventor. So upon import, you will get the option from a model tree to select the components to bring in. The import dialog box has also been simplified down, so this is now what you're greeted with when you choose to import a file into Inventor. You can see at the very top we've got reference or convert model. So reference model is what utilizes the AnyCAD functionality to enable us to link back to an existing CAD file. If you hover over the little eye that you can see on screen, that is what will happen. You've also then got object filters, Inventor length units, multi-body assemblies, so it's a little bit simpler to understand. If you go on the Select tab, what you then get is the ability to select components from the list, either visually from the model browser or on screen to say yes, include this, don't include this. I want this component, but I don't want that component. So it's going to make it a lot slicker for you to work with someone else's data from another system. As far as AnyCAD is concerned, this is the first implementation of this into the software, so there are going to be a few things about it that you need to be aware of. As far as an associative update is concerned, these are the files that Inventor will work with in terms of being able to associatively update. In other words, if the CAD data changes in the native system, this is what will update within Inventor. Just to point out, although it says SolidWorks up to 2014, I have seen this work on SolidWorks 2015 as well. So the associative update works with all of the CAD formats you can see listed, obviously the ones with the tick in the box, so right the way down to AutoCAD 2D, which we are going to come to in a moment. Excuse me. And then Selective Import, which is the dialog boxes I've just been talking to you about. That is available for every CAD system that you can see on screen. So it really gives you the flexibility to work with a multitude of CAD systems really, really quickly and easily. So now if you want to place something in an assembly, as well as place from Content Center, place iLogic, and place electrical, if that's what you had, if you've got the electrical aspect of the software as well, you will also see a place imported CAD file from the drop-down list to work with. AnyCAD also supports the ability to import properties from the third-party CAD system. So not only are we bringing in just the geometrical data, we can also start to bring in and map properties from other CAD systems. So I could map the properties from CATIA or Creo or NX or SolidWorks. So those are in the install directory, so C users public documents, Autodesk Inventor 2016, design data import properties. Can pause the video just to make sure you get all of that. There are a few XML files, and these XML files essentially look a little bit like this, and you can use them to map one file to another. So you can use to map them. So there's a SolidWorks, a CATIA, and a Pro Engineer Creo one at the bottom there, I think. So we have a quick little video of AnyCAD. Obviously AnyCAD is the ability to work with different CAD systems from well, yes, the ability to work with different CAD systems, so it's slightly different. So we've got a little live demonstration here of what we're going to run through that I've recorded. This is a video. So in this particular video I'm working with a trial version of a different software, just to sort of get an idea of this. So we can open up in AnyCAD, we can open up our assembly in Inventor. So nothing new there. I've opened from Vault my assembly. Now what we're going to do is we're going to go and place something from an imported CAD file. So I'm now going to browse in my workspace to another assembly. So I've got an assembly file. Take a note of the name. .7 is the assembly. I can select, upon select, load the model. I can see the model that we've got, and I can start to pick components from this. So I can select components and I can say, I don't want that one, I do want this one. In this case I want everything, so I'm going to select everything and I'm going to click OK. So I'm making sure I'm referencing the model, making sure I set the length units and click OK, and that'll then bring that model in. Just to highlight as well, the little I does tell me that this gives me a link back to the original CAD file. So we can click OK, bring that in. I can then use the normal standard rotate around X and Y and Z to orientate the component, make sure it's in the right place, and you can see roughly where this is going to go. So I'm going to place this roughly where it should be, and I'm going to click OK. Now we're going to go to town about constraining it. So I'm going to constrain face to face, align those two together. That's OK, I can drag it out. What I'm then going to do is constrain top face to top face, again making sure that we've got those constraints locked in. Final one is I'm going to constrain side face to side face to make sure those components are in the right place, and that works really well. So when that's done and the components are in place within Inventor, I'm now going to place something else in the assembly. So I've accepted the component from my supplier, I've brought it into my CAD system, I've put it in my Inventor assembly that's constantly evolving, and now I'm going to assemble another component to this. So I'm assembling something else within Inventor. This is a native Inventor file, this one. So I'm importing an Inventor file. Just to make you aware as well, if you look on the left hand side, you can see the ACAD_ARM. It has a different symbol to the other standard assemblies that we're working on. So you can get an impression from the model browser as well that it's not a native file. So I'm going to import and I'm going to assemble axis to axis, and I'm going to apply that and make sure that's in place. And I'm then going to do the same thing and align face to face. So I'm going to align two faces to this. So pick face and one more to make sure that's in the right place. I could at this stage as well align it so it still moves in this orientation, so we might just do one more of aligning face to face with an angle constraint. So we'll make this face and this face point in the same direction. Make sure it's on the angle. Work the way through the video. So leave it in position for now. There should have been an angle constraint. Wish I could talk to myself recording the video. So anyway, we've got that in place. We can then pattern this. So if we wanted to, it is, although it's from another CAD system, we can still import it, we can still pattern it. So I'm going to specify some values in here to make sure I pattern this in the right direction, flip the direction, and it's exactly where I want it to be. So I have my Inventor assembly created, but if we have a look at it, you can see that on the elements we've got, just expanding to show you where we've got the files from a different CAD system. So if we were to do a little inspect, the holes are actually too large, so we can browse to a different CAD system. So this is a different CAD system running as a trial just to sort of demonstrate this. So we can open that up, get rid of all the mess in the background, just make some quick changes to the file. So I'm just going to quickly tidy up the model and make some changes to this particular file. So I'm going to open up one of the parts, which is the main arm that we've got in here. You can see we've got a full model browser on the left hand side, we've got all the information in here. So we've got some changes. I can make a change to the holes. When I make a change to the holes, so the holes are the wrong size, just nip back. I can go back in here and say, well, these are not 9, they should be 5, so I can change them. They'll then shrink. And we'll also make a change to the base extrusion as well. So we're going to change the base extrusion in here and say rather than be 100, we're going to make that 175. So we're elongating the part file. When we've done that, we can then close this down, make sure we save the assembly in the other CAD system. So obviously this isn't something that you would be doing. You're the Inventor user, you're just receiving this file in, so that bit there is a little bit of what someone else might do in a different system. Now I'll come back into Inventor, but you notice there's no update, automatic update involved. That's because some CAD systems save with a .version number. So in order to get over this, we can simply delete that file and change this file to a different .version number. As soon as I do, if you watch the update at the top of the screen, as soon as I do, and I accept the Windows error message, as soon as I do, I then get a little update symbol at the top of my Inventor screen. So we'll close down that window, and now I have an update to run. So I can run the update from the right mouse button there, or I can run the update from on the screen. So when I do run the update, you can see it's changed the part file. Now notice the thing that happens in terms of a failure. It's told me that it's lost some relationships. I'm going to point this out to you in a moment and explain what all this is about. But you can see, if I just delete those constraints and reposition those components, that whilst I'm doing this, the holes have changed size, the components have been updated, and all I'm doing realistically in this instance is now just recreating the relationship. So I'm literally just creating the relationship again between components and reference. That's all I'm doing. And we've now have a live link back to the existing CAD data. So hopefully that demonstrates the idea behind AnyCAD. Do's and don'ts, things to be aware of. So I pointed one of them out during the video there. If you constrain to a face and the face is moved, the constraint will fail. You can use the new delete all SIP constraints in order to fix this. And this is something that you can overcome. So in the experiments that I've done, you can overcome this by creating datum geometry, so almost building up a sort of a layer of insulation between, rather than picking a central axis, you can create a datum axis that belongs to that geometry and reference your Inventor constraint to the datum axis. Then what happens is that because of the order of regeneration, Inventor then regenerates the model. It might elongate it, which in turn will move where the axis is located. The axis will move, and then the relationship between the constraint and the axis is then updated. So you can get around that. You can work with it that way. Another thing to make sure you're aware of is upon import, make sure you set the units to match the existing assembly. Otherwise, importing the file will change the assembly to whatever units you're working on. So, I mentioned as well a moment ago with AnyCAD that it gives us the ability to work with AutoCAD data. So AnyCAD gives us the ability of what we're calling a DWG underlay. So if you have DWG data from AutoCAD, you can now underlay it into Inventor and maintain the associativity. So this is the really powerful aspect of this. So what AnyCAD enables me to do is have an associative update where I've got layer visibility control and I can suppress and break the link, turn it on and off as and how I want. So I'm going to have I've got a really quick demonstration here of AnyCAD working with a DWG. So I'm going to create a part file, create a brand new part file, start a new sketch. I'm going to import onto a plane. So I've got a plate. This is a standard AutoCAD file. You're going to see the AutoCAD file in a moment. I'm placing it in. It just gives me a warning because I haven't saved it. But it then tells me that doing this will give me an associative underlay. So my associative underlay enables me to start modeling geometry and create a relationship back to my AutoCAD part. So if I make a change in here, so we're going to use some of the dimensions and the values that we've got. We're going to take that profile, use the project DWG underlay icon, and I'm going to project some points in here as well, and this is then going to allow me to start working with the geometry and creating dimensions. So I'm going to create a dimension between these two. Obviously this is going to be a reference dimension because it's governed by the fact that this is controlled externally, and then when I've finished I can simply finish the sketch and really quickly create an extrusion of my profile that I've just copied out of AutoCAD. So my dimension value, this is where you can start being intelligent. If I link my dimension value to the reference dimension I've created, in effect I've now got a fully controlled AutoCAD Inventor file that's controlled by AutoCAD. So now if we nip back into AutoCAD, we can have a look at this, we can see the geometry, and we can use just simple tools, just like simple stretch commands, so maybe make modifications to a couple of the holes that we've got in here. So all this is doing, all I'm doing here is making changes, standard AutoCAD geometry. It could be me doing this, it could be my supplier doing this, it could be anybody else doing this in the same company. We use the stretch tool, so make sure we use stretch. Window select around those, and that then is going to let me move this point, and I can set this to a set distance, moving it in by a set distance if I wanted to, or I could just move it in as and where I need it to be. So I'm just going to move it and drop it in place. Make sure we get the stretch right. And just drop it where I need it to be. So I've made a change to that geometry really. I've moved it up by 10. And we've modified the stretch geometry. So once we've made the change, we can then move over to the rest of the model, and we can then afflict more changes if we need to. So let's stretch the base out, maybe at an angle if we want. All of this is fine, I'm just demonstrating that we can make quick changes to the model. So once we've made the changes that we need to, we can then finish off the geometry. So you might take some circles and move them around, or take a copy of them, duplicate them. Really quickly just duplicate the geometry, and then we can carry on working with what we're doing. Come back into Inventor, and inside Inventor that's then going to give me the ability, make sure we save the file, then when I update it, it will then give me an updated CAD file within Inventor. So you can see we've got a link between AutoCAD and Inventor. I can take my extrusion, I can come in here and maybe edit the profile and add in those existing shapes if I need to as well. But this is just to give you an overview and demonstration of this. So that hopefully should give you a good indication of what AnyCAD can do in relation to a DWG underlay. Again, there are things to remember, do's and don'ts. To make sure in the DWG file we have the same units and we're working in the same units between files. If you decide to project any AutoCAD block geometry, when you use project DWG geometry, if you change the block, it will then subsequently have a failure when you go back into Inventor. So if you change a block and that block is referenced, you will then cause a problem. It's just a case of re-referencing it, but it's just something to be aware of. Again, the AutoCAD file, if you have any associative arrays in there and you change the original file that's linked or used for an associative array, any projected geometry will fall over. However, if you decide to use the legacy array where it's not associated, that will work perfectly fine as well. So that's me just about done for AnyCAD and advanced manufacturing and sheet metal. I hope you found it all useful. We will be running some more videos like this that will give you some of the more functionality for 2016 Autodesk products.